in the session that just concluded, I obtained the acceleration capital A of the inclined plane, right? mg sine theta cos theta by capital M plus small m sine square theta, etc. I also obtained the relative acceleration of small m with respect to the inclined plane along the plane, right? And I said to you that the resultant of these two will give me the acceleration in the ground frame, right? And what I did was, with this basic premise of capital A and small a giving me the net acceleration in the ground frame of reference, I chose to write my equations of motion in two mutually perpendicular directions, perpendicular to the plane and parallel to the plane, right? Now I'm not going to do anything new. All that I'm going to do is I'm going to write my equations of motion along the horizontal direction, which I'll call the x direction, and in the vertical direction, the direction of Mother Earth, and that is the y direction. And I'm going to show to you that we are not getting anything different. Why should it be different? The whole thing is very well cemented and bonded. So no matter what, if we don't goof up, we'll get the same thing, right? So like I said, the resultant of small a and capital A will give me the net acceleration. And I this time choose to look at things horizontally and vertically. So in the horizontal direction, the net acceleration in the ground frame is going to be this A resolved in this direction as A cos theta and capital A. So A cos theta minus capital A, right? A cos theta minus capital A is the acceleration of small m along the x-axis. In the y direction, it's like a sine theta. It's like a sine theta this way, right? So in the ground frame, ax is A cos theta minus capital A. In the y direction, ay is A sine theta, and I'm going to apply Newton's second law along the x-axis and along the y-axis based on these forces. What are the forces acting on small m? There is mg like this, and there is capital M perpendicular to the plane. And capital M could be resolved in the y direction, vertical direction as n cos theta, and horizontal direction as n sine theta. Clearly, mg minus n cos theta will produce ay, and n sine theta will produce ax. This is what's going to happen, right? And of course, like before, from the inclined plane perspective, n sine theta is capital M into A, which is the unbalanced force acting on the inclined plane, causing the inclined plane to have an acceleration capital A to the left, right? Good. So let me write equations of motion along the x-axis and along the y-axis. So along the x-axis, for small m, we have n sine theta doing the following. Acting on the mass small m to produce ax, m into A cos theta minus capital A. A cos theta minus capital A. This is what it's doing, right? That's as far as n sine theta is concerned. What about the vertical direction? Vertical direction, let's write as, so let me call this equation 3, because these were equations 1 and 2. In the y direction, I have like a mg minus n cos theta mg minus n cos theta, and that's going to give me mass into A sine theta. That's equation 4. That's equation 4. All that I therefore need to do is to solve for small a and capital A from this equation, small a, capital A, and n. From this equation, and equation 1. This is what I need to do, right? And we are not going to get anything different from what we got earlier. If I solve for capital A from these two equations, let me tell you the final result, if you allow me. I'm going to get capital A as mg sine theta cos theta divided by capital M plus small m sine square theta, not any different from before, and small m as capital M plus small m g sine theta divided by capital M plus small m sine square theta. This is what I'm going to get as capital A and small a. So this is just to make sure that you understand that all roads lead to Rome. I have not communicated anything different. It's just that, I chose to be cosmetically different. But eventually, being cosmetically different doesn't mean that you're going to get different conclusions out of that. Conclusion would be the same. You might take to different routes, but as long as you're not goofing up algebraically or conceptually, then taking to any route is fine, and resolving forces along the y direction and the x direction and writing equations of motion commensurate also did the job for us. Thank you so much. I hope you're enjoying all of this, but we have not done. There is a lot of things. Next, what I'm going to do is I'm going to look at the same problem. The same problem. I have written my equations of motion from a ground perspective. I've taken only real forces, n and mg on small m, the particle, and I have applied equations of motion along the x direction and the y direction and solved the problem, right? That is in a ground frame. So all my solutions so far have been in the ground frame, but I'm not averse to the idea of looking at the same problem in a frame of reference attached to the inclined plane, which would be my next agenda. Thank you so much. Bye.